All right, part two of chemical reactions. We left off talking about different ways to write a chemical reaction. That you can use, well, sentence form. You can use word equations. You can use what we're looking at now, skeleton equations, and eventually getting into balanced equations. But you have to be able to do what we did in chapter 9, nomenclature. I got to be able to take it. If I say solid iron 3 sulfide, I need to know that's Fe2S3. And like I said, the S and the G that you put after these equations are just the state of matter. I could do without those. In fact, in your homework and stuff that I included in this, so you're not going to probably have to include that. If you want to, great. It's more so being able to get the equations written down, because once I have the equations down, I can see here that there are 2 iron on this side. Well, there's only 1 on the right side, on the reaction side. So I'm going to have to balance that somehow, because I know that doesn't satisfy the law of conservation of mass. That says the number of atoms on each side, atoms and matter cannot be created or destroyed. So here I'd be destroying 1 iron atom, and I wouldn't be able to do that. So I have to be able to write it. And just to give you a quick review, iron 3 means it had a +3. Sulfur had a -2, hence we crisscrossed to get this formula. And then hydrogen chloride +1, -1, so I didn't crisscross. If we look at iron 3 chloride, again, the 3 in the parentheses means that iron's a +3, so that comes down here. Chlorine's a -1, I didn't have to write it, and so on. So that's kind of the first part. To be able to write the skeleton equation, you have to be able to take the names in word form and then be able to put them into their formulas. And you can look at number 2. It's the same way. Carbon dioxide, using some of the covalent molecular compounds. Di meaning 2, so there was 2 oxygen, and so on. So now let's look at the last type, which was balance that chemical. As I showed in the last example, how there was 2 iron in the reactants and only 1 in the product. There's something that happened. The number of atoms you start with is the same that we have to end up with. So that's what it means when you say balanced equation. And as you move forward throughout the rest of chemistry, if they give you any type of equation or a word thing, you have to start with a balanced equation. That's the number one thing. So we have to be able to make sure that the number of elements on each side match up. Well, here are your rules for doing it. Number 1, make sure you have the correct formulas, the reactants and products. That means you got to make sure you got the words right, because if I don't write the formula down right, I'm going to have the wrong number of and types of atoms. So start off by putting the correct formulas, writing that skeleton equation, changing the word plus into an actual plus sign and yields into the arrow. Number 3, count the atoms of each type that are appearing on each side. So figure out what you have first, and then balance them by only changing. Number 4 says only changing the coefficients. That's the number that comes in front. I can't change subscripts. Kind of a little hint there in yellow is save balancing hydrogen and oxygens to last, because they come in multiple different formulas in chemical symbols. So it's best just to save the last, and a lot of times they work themselves out. At the end, number 5, like any math equation, double check it. You can always double check to make sure they equal out. Never change a subscript. That's this number down here, the 2. I can put a number in front of it and say I have 2 hydrogen peroxides, but I can't change the number in front because I changed what the formula is. And then you can't put a coefficient in the middle of a formula. If this was salt, NaCl, Na was +1, Cl is -1, they stick together. I can't separate them to put a 2 in front of it. The number has to come in front of the formula. And this formatting, when I switched over to the Google Slides, came out a little bit off. As you can see, they're down a little bit. But here's the skeleton equation, not the 2 down there. That should be up in the blank space, and this 2 should be up. But what I would do going through this first one is 1 silver, 1 silver. I wouldn't do anything yet. Now, I would keep this NO3 together, because that is nitrate. This would be silver nitrate, if you remember back from naming polyatomic ions. This is also nitrate on this side, so I don't have to separate it into nitrogen and oxygen. I can keep them together. I would say I have 1 nitrate on this side, but how many do I have on this side? If I look at what's in the parentheses, I have 2 nitrates on this side. Hence, I would come over here and put a 2 in front of this whole thing just to balance my nitrates. But once I do that, by putting a 2 in front, I also put the fact that there's 2 silvers now. So I have to go back and look at silver and say, well, now I have